This is my Edpuzzle video, and today I'm going to connect three important aquatic science concepts: properties of water, the water cycle, and the water treatment process that makes our water safe to drink. These ideas show how water works in nature and how humans manage it. Water has many important physical and chemical properties that make it unique. And today I'm going to focus on three of them: polarity and molecular structure, the relationship between density and temperature, and the water's ability to act as a solvent. First, we're going to look at polarity and molecular structure. A water molecule is made of one oxygen atom and two hydrogen atoms, shaped like a V. The oxygen pulls electrons more strongly than the hydrogen atoms, so the oxygen side becomes slightly negative while the hydrogen side becomes slightly positive. This makes water a polar molecule. Because of polarity, water molecules attract each other and form hydrogen bonds, which give water many of its special behaviors. Next is density and temperature relationship. Most substances become more dense as they get colder, but water is different. Water is most dense at 4 degrees Celsius. As it continues to cool and freezes, it becomes less dense. That's why ice can float on water. This property helps insulate lakes in the winter and protects aquatic life from freezing. Finally, water has solvent properties. Because water is polar, it can surround and separate many types of molecules. This is why water is known as a universal solvent. It can dissolve salts, sugars, gases, and many other substances. This ability allows nutrients, minerals, and chemicals to move through organisms and ecosystems. An example of this is in plants. They use cohesion and adhesion to move water up the stems. Now that I explained the basic properties of water, we can take a look how water actually moves through the environment. This is known as a hydrologic cycle, and it's one of the most fundamental and basic concepts of water. The water gets recycled through the Earth's atmosphere and the ground. Evaporation happens when sun heats liquid water and gives the molecules enough energy to escape as water vapor. We can see this in oceans, lakes, puddles, and basically anywhere where water is exposed to heat. Once that warm vapor rises, the air gets cooler, and that's when condensation happens. The vapor slows down, sticks with tiny particles in the air, and forms clouds. Evaporation moves the water up, and the condensation gathers it as a cloud. When the clouds fill with a lot of water, precipitation falls, either as rain or snow or ice. Some of that water stays above ground and it goes into rivers, lakes, streams, and oceans. Surface water is what we can see and it's what we use for drinking and recreation. But some of that water goes into soil, where it goes downward and eventually hits layers to hold and store it. Stored water is called groundwater, and is kept in layers called aquifers. In Texas, both surface water and groundwater are major sources for drinking water, farming, and cities. Surface water in Texas comes from rivers like the Guadalupe, San Antonio, and the Colorado River. Groundwater comes from aquifers such as Edwards Aquifer, which is especially important for Central Texas in the San Antonio area. These systems work together to support millions of people, especially because Texas has long, hot summers and sometimes even periods of drought. Without managing these systems, the state would run out of water fast, and we wouldn't have it for farming, drinking, or recreation. When our water systems get too polluted, we have water treatment processes to clean it. Water treatment plants use a series of steps to remove contaminants before the water reaches homes. First is screening, which removes large objects like sticks or trash. Next is coagulation and flocculation, where chemicals cause tiny particles to clump together into bigger pieces called flocks. Then the water goes through sedimentation, where the flocks settle to the bottom. After that comes filtration, which removes anything still left, like bacteria or sand. Finally, the water is disinfected, typically with chlorine or UV light to kill harmful microorganisms. Each step targets different types of pollution, and it makes sure that our water is safe to drink. But even with this treatment, human activity still affects the health of aquatic systems. Human impacts show up in streams, rivers, lakes, oceans, and all our water. Runoff from cities increase nutrients and chemicals in waterways, which can lead to algae blooms. Construction and land clearing add sediment that clouds water and harms fish. Overuse of groundwater lowers aquifer levels. Plastic pollution harms water life. Urbanization increases stormwater, which carries pollutants directly into rivers. The health of aquatic systems is directly linked to how humans build, farm, and live. Changing those behaviors is the most effective way to protect water quality long term.